I'm going to give a short talk, hopefully no more than about 20 minutes, so that we can get into the applications on Polyglot ClickHouse. So this is about just the many ways that ClickHouse can integrate with remote data, and this will be from the perspective of ClickHouse reaching out to other things. So let's just dive in. Very quick introductions. So my name is Robert Hodges. I'm the CEO of Altinity, but I've been working on databases since 1983. ClickHouse is number 20, I think, but you sort of tend to lose count after a while. And this picture is what I look like when my examples are working. Altinity, which I think many of you know already who are on this call, we are the enterprise provider for ClickHouse. So we work very closely with the core developers. We have a substantial engineering team of our own. In fact, some of the things I'm going to talk about were implemented by Altinity. And we do a lot of community sponsored activities in both the US and Western Europe. So running the San Francisco ClickHouse Meetup is one, of course, when we could all still take plane rides. We did a lot of sponsoring of other events. So that's it for Altinity and me. What I'm going to do is dive in and just talk about this notion of ClickHouse and being polyglot. What I'd first like to do is, I know we often have people who've never met ClickHouse before and you're here for the first time, so that's really great. So here's just a quick introduction of what ClickHouse is. So ClickHouse is an analytic database, and the way I sometimes explain it to people is, imagine if MySQL, which is a really famous open source database that just about everybody's heard of, and Vertica, which is a pretty famous column store that just about everybody who does analytics or has done it for a while has heard of. Imagine they got married and had a baby. So that baby would talk SQL, because both parents talk SQL. It would, like MySQL, run on pretty much anything, so bare metal to the cloud. Like MySQL, it would be open source. In this case, ClickHouse is Apache. It would be really fast. MySQL is not super fast in analytics stuff, but on transactions, it's extraordinarily fast. And then from the Vertica side of the house, it would have a bunch of SQL functions and features that are optimized for analytics. It would store the data in columns so that we get efficient compression and can read, sort of choose the parts of the storage that we want to read more effectively. It would have things like parallel and vectorized execution, and it would scale to many, many petabytes. So ClickHouse, I don't even know what the largest cluster of ClickHouse is by number. We think it's somewhere in China, and it's in the many hundreds. Yandex runs about 500 nodes. People like Cloudflare run 100 plus and ingest 20 million events per second. So it's really big. So that's ClickHouse. It's a great piece of software. If this is your first time hearing about it, definitely don't believe us. Just go check it out yourself. It's really easy to get to. So what I'd like to do is dive in and just talk about polyglot databases. And the first question is, what do we mean by that? Because I just kind of made up that term. And the idea is that you have, the real question is, can your database talk directly to other sources of data? And so traditional relational databases like Oracle, like Sybase, like Informix, the systems developed back in the day had very limited ability to go look at data in other locations, so, or integrate with them. So what you would end up doing is you would have some sort of translation app. So for example, if you were talking to a NoSQL database, you might have some app that, a broker that would move data back and forth, or message systems. You would have, if you didn't have it built into the database, like the way Oracle does, you would write apps that would move stuff back and forth. So that's a non-polyglot database. It basically talks to its own data. On the other side, a fully polyglot database can talk directly to all kinds of interesting stores. So, and I've just got 4 types here: object storage, relational databases, NoSQL, and event queues. These are not the only things you'd want to talk to, but the point is that if the database is polyglot, it can connect to them directly, and you don't have to write applications, set up pipelines, or any complex, or, it reduces the complexity. So if you look at ClickHouse, it's definitely polyglot. This is a short list of, in this slide is a short list of all the things that it can talk to. I don't believe it's complete. I'm sure I have missed a couple. So, but there's just all kinds of useful things like object storage. You can talk to ODBC, you can talk to Cassandra, just and then there are more on the line as we'll see in this talk. So that gives you a lot of opportunities to go get data from, basically access data in other locations and pull it into to Postgres for further processing, or just access it remotely for to join with data that's in ClickHouse. And the specific mechanisms that ClickHouse uses they're basically four of them, four ways that ClickHouse can talk to a remote data source. One is to use a database engine, and I'm going to show you an example of how MySQL does that, because there's a very nice implementation of that. Another one is table engines. So table engines wrap things in the outside world, or actually inside ClickHouse itself, and make them look like tables. It's basically the thing that contains all your access methods and allows you to insert data, allows you to select data, so on and so forth. So that's another mechanism. There's a number of table engines that talk to external things. There are table functions. These are actually functions you can execute in SQL, which return tabular results, and we'll show you a couple of interesting examples of those. And then finally, there's dictionaries, and dictionaries are lookup tables. You can think, in fact, they're basically organized as big hash tables that can pull data from other locations, and then you can join with them. Because this talk is kind of short, I'm just going to do the first three and leave dictionaries as an exercise. There's definitely a bunch of interesting things going on there, but I think for moving data, the first three are the most interesting. So what I'm going to do now is go into four examples of different ways that you can talk to databases. I'm just going to show you how to set it up. So the first one, and this is actually one of my favorites, is to access MySQL data using a database engine. And the basic idea is, let's imagine that we have a database out in MySQL and we've got three tables in it. So the database is called REPL, and it's got a traffic table, a customer table, and a SKU table. And so these are completely inside MySQL. And what we would like to do is be able to issue queries on them from ClickHouse. So it turns out that ClickHouse has this great thing called the MySQL database engine. And what it does is, you basically, when you create your database, you give it a name. That's, for those of you that use ClickHouse, you see these, you're familiar with these commands. And then you give the connection information for the MySQL database. And once you've created it, at that point, MySQL knows how to talk to, ClickHouse can talk to MySQL. So the commands that are shown down here on the lower down on the slide, like use MySQL REPL, we're actually going and using the ClickHouse database, using a normal use command, and then doing a show tables. And so at that point, all those tables I just showed you in the previous slide, you'll see them just as if they were local to ClickHouse. And this runs very quickly, and is quite transparent. Another thing that you can do is then you can select MySQL data from ClickHouse. So this is a query which was run from ClickHouse, and it looks, for those of you who are familiar with ClickHouse, this syntax will look fairly familiar. Basically, we're joining a couple of tables, and so ClickHouse is actually going to go out and run those queries. And it turns out the MySQL data engine is pretty good in the sense that it has a fair amount of knowledge about MySQL semantics. And for example, it knows that it's doing a join on a couple of MySQL tables. It will push down that where customer ID equals 5. That predicate actually gets pushed down to MySQL, so it reduces the amount of data that's selected. So it's really a very good way of looking at data on MySQL that doesn't require a lot of setup. And I didn't include this because I wanted to keep the talk short, but just in a nutshell, there are even cases where ClickHouse can run these queries faster than MySQL can, and the reason is that ClickHouse is pretty good at parallelizing things. So depending on what your query is, you can sometimes get faster results inside ClickHouse, which is really kind of an interesting result. One of the things you can do, though, for this, in addition to just running queries on, sort of joining on data that's in MySQL flexibly, you can also use it to suck data out of MySQL and then populate ClickHouse tables, and then you can run normal ClickHouse tables with them. So we'll show examples of population in a minute. But that's the first one I wanted to talk about. And I don't know if anybody's used this, but if you have questions about it, feel free to throw them out. The next one is accessing Kafka using a table engine. And about half the people that we've run into that use ClickHouse are using Kafka. So it's a really great way to to be able to load data, ingest it very quickly into ClickHouse. And when this was first when ClickHouse first became open source, most people would write an app that would read from a Kafka topic or one or more Kafka topics and just generate inserts and stick it into ClickHouse. A couple of years ago, and maybe more like 3, when Cloudflare started to use ClickHouse, they developed something called the Kafka table engine. And so the way that this works is, if you're familiar with Kafka, you know that messages sit inside topics. That's kind of like a queue, and that multiple readers can access. And so what the way that this works then inside ClickHouse is, you set up a Kafka table engine that encapsulates the topic and makes it look like a table. You then have a target table at the other end, which is where you want the rows to land, sort of the records that are coming in from Kafka. And then what links them together is a materialized view. Materialized view is like a trigger on a table. And so basically what it does is that the messages will flow into the Kafka table engine, or it'll be watching them. And at some point it just says, I've got enough. There's a parameter you can set to control how long it goes. It'll fire the materialized view. They get transferred to the target table. So this is a very simple way of integrating with Kafka that doesn't involve pipelines and extra apps. Here's just quick examples of how you do this. Here's a target table called readings. So it's just a normal merge tree table, partitioned by, it looks like I left something off because I don't have a sort order. I don't think ClickHouse would like that. So it is basically a normal table. And then here's the Kafka table engine. And for those of you who are familiar with Kafka, these will look pretty standard. Things like where the brokers, what's the topic, and you can have multiple topics. What's your consumer group name? That's used for transactional support. You can have a bunch of consumers. And then a really important and interesting thing is the format. This is saying that the messages arriving in Kafka are CSV, so we should apply the ClickHouse format to them, and which we'll use then to translate the data in the table. So formats are actually really important in these types of integrations, because they allow ClickHouse to understand what is the form of the data in cases where it's not obvious from looking at it. So that's Kafka. This is pretty popular and used by a lot of people. There's still a fair number of people who've developed their own applications to transfer data from Kafka topics into ClickHouse, but this is, if you want to get quick access to Kafka, this is something you should consider setting up. Okay, and here's the materialized view. I forgot, I mentioned that, but it's really simple. So, so this is like 3 little bits of code and you're off and running. So the final examples that I want to show are accessing S3 and Snowflake, and I see there's a support for querying non-default region in S3. I'll get to that in just a second, because it tortured me while I was setting up these examples. So let's look at S3. So the Kafka is great for ingesting messages at scale. So that's really important to be able to transfer stuff easily. MySQL is really good because, well, there's transactional data. There's often things like dimension tables, which are convenient to store in MySQL. S3 has a unique role because it's a really great place for bulk transfer of data. And so I'm going to give you some quick examples that show you how this works. So what I'm going to do here is, this command shows you how to use something called the S3 table function, which is just a function that will basically load data into your select as if it were a table. And what this does is, you can see the parameters here. So you've got a bucket name and actually a series of files, and you see the wildcards. And this form, you have to use this exact form of the host name followed by the bucket, otherwise wildcards won't work. You have your access key and your secret key. You have your format, which in this case is CVS with names, so CVS with columns, and then you have a definition, so a schema definition that tells you what to do. This will go out and it'll find every CSV file that's in that location with the wildcard, and it will go ahead and load it. There's also a cool setting, max insert threads. If you put this in, it will parallelize the inserts, and we use this commonly to load data from very quickly into ClickHouse. We did it recently for Redshift. So that parallelization is super helpful. You can then, but what's kind of cool is it's not just reading, you can also write things back. So I inserted, just to be clear on this, what we're doing is we're inserting into a table called sData by selecting the data out. So we're out of S3. So we're selecting the data and wham, it goes into the table. What I can next do is I'm going to take the table, the data from that table that I read from CSV, I'm going to write it out as Parquet in S3. So here's an example where you say insert into table functions. Table functions behave as tables, most of them, and you can actually, or many of them, and you can actually insert into them. So we have the same type of definition, only you'll notice the format is Parquet. I have a different URL format, which I'm only using here because it describes, it shows that there are different ways of doing it. And if you use this form, it doesn't support wildcards, which is not good. That's something you can bump into and really scratch your head until you figure it out. So this tells you, where to write and what to write, and then out it goes. So it's selecting the data. And then finally, once it's back out in Parquet, we can select it back. So in this particular example, I didn't even see the data until I'd sucked it in, written it out to Parquet, and then I selected it back from the Parquet file, and then I see the exact values that I was loading. And the question that came up was, when do we get support for querying the non-default region in S3? I believe that's, okay, so here's a really important thing on S3. Do not use it unless you're running at least 20.6. There's a number of, it's available in 23. It's not particularly, it's not as stable, but not fully stable. In 20.6, it's getting better, and there is a problem where you can, you basically can have to play around with, like basically there's some limitations to what buckets you can select from. And one of the problems that I had when I was setting this up is it wanted to go to US East, which is kind of limiting. That is being worked on right now. I do not have a timeline for when it's going to be fixed, but what we are going to be doing is putting some effort into more general testing. This also needs documentation. So the feature is usable right now, but you definitely have to play around with it quite a bit. So that's S3, which is, if you have to move bulk data, is extraordinarily useful. And then the final thing is ODBC, and here's an example that I don't know if anybody has done before, but it turns out that you can get Snowflake data into ClickHouse, and the way that you do it is, if you're using Snowflake, go grab their ODBC driver and configure a Snowflake data source. So this is an example of the Snowflake data source configured using Linux ODBC or Unix ODBC, and the version that runs on Linux. And then what you can do, and if you've used ODBC, this will look pretty familiar. It's fairly easy to set up. Then what you can do is, in this example, I went and created a table. This is some demo data that Snowflake gives you. It is fairly small, which is why I picked it, because it's good for an example. So I make a table with 4 columns. And then what I did was I went ahead and inserted data into this table by selecting it from the ODBC function, reading off that data set, and looking for schema TPCH and SF001 and table nation, and it actually pulls the data in. So this works. You'll play around with it if you are, if you're, and if you're familiar with ODBC, you can get it to work. This is definitely experimental. There are things like case sensitivity you have to be very careful about. You I've found it very useful to use the Snowflake history in the console. There are some other issues, like if you wait long enough, the authentication will time out, and then it seems like you have to restart ClickHouse to get it to work. But this is stuff that I don't think anybody has really tried before. So if you do try it out, log issues, they will get fixed. So so anyway, that's a cool example. And then just to complete it, this is what the data looks like when you actually select it in ClickHouse. This is exactly the data that was in my sample Snowflake database on my account. So that's kind of cool, and definitely opens up some interesting possibilities. I would say if you were moving data from Snowflake, I would move it through S3 for sure. So, you know, sort of dump it to S3 and move it that way. That's just much better. One of the key things about ODBC is it's not going to parallelize particularly well. So, so you would probably do better loading through S3. That's the talk. I hope I haven't gone too long. So takeaways. So ClickHouse can talk to a wide variety of stores. It's you know, basically is, you know, there's a lot of things that you can connect to. The stability is variable. I mean, ClickHouse is an open source product. Things are constantly being added. People are adding this stuff because they have a particular use case they need to answer. And just sort of looking at the examples we had, MySQL is pretty stable. And I see a question coming up. And okay, this is an interesting question. MySQL is pretty stable. S3 is very new. It's not documented formally in ClickHouse. That's in the queue to be done. It needs more testing and more pounding. A lot of the work was done actually on S3 compatible APIs. So you're likely to run into some problems, but they're being fixed. And then data stores like Snowflake, accessing it through ODBC, that's a complete experiment. It works, but what I encourage you to do is try it out. I mean, ODBC is just like this gateway that talks to practically everything. Try it out, post the issues, help us make it better. And the Polyglot capabilities are improving very quickly. They really are getting better. S3 was fairly unstable. It's improved quite a bit over the last few months and will get far better. There's a very interesting engine coming called materialized MySQL, which will enable ClickHouse to read directly from the MySQL bin log. So you'll be able to build replicas from a MySQL master, and that's coming in 20.8. There's a PR for that is being worked on by one of the Chinese service providers. Lots more reading. I'll leave this. You can catch it in the slides, but check out clickhouse.tech. There's great documentation, and then the Altinity blog. We will be blogging on these topics and have more information about how to use this stuff effectively. And we're hiring, so if anybody's interested, we have a bunch of positions open. We love databases, and so if you're a database person and you like clouds and you like analytics, check us out. We'd love to talk to you.